This video is intended to give a sneak peek for a new feature in the upcoming ADAPTBuilder 2019 that is related to the calculation and use of effective flanges for beams. We're going to go ahead and launch Builder, and this will be a version of Builder 2019. We're going to do this relative to RC model. So we'll go ahead and we're working in Floor Pro for this example. We're going to set up a grid here and we'll use 10 by 10 spacing. I'm going to model 24 by 24 inch columns. And we'll do two 30-foot spans. And we're just going to go ahead and copy those columns over. Also 30-foot bays in the X direction. And then we're going to model some beams. So these might be post-tensioned or RC beams with a one-way slab, for example. We'll make the beams 24 by 20 by 21 inch deep beams. And I'll select those and copy those to the columns. Okay, and then we're going to model a slab on the perimeter. So I'll turn off the grid. I want to turn on snap to vertices of components here with snap to endpoint. And now I can model an 8-inch slab on top of the system here. Now the way the program will calculate effective flange automatically is dictated by the design code that you've set in criteria. So under design code, when the user selects European code or Brazilian code, the program defaults to European code calculations for effective flange. Every other code that the user selects would default to ACI. If you want to use something different than that, then the user would have to use more of a manual procedure for using splitters and bounding off the effective flange. So to start, we're going to set this to ACI 2014, and we're going to just refresh on how the program currently in version 2018 handles, let's say, effective flange. So we're going to go up to Floor Design. I'm going to select the option for creating a design strip. Before I actually enter the strip, I'll change the design section settings to beam criteria. Okay, and we're going to go in and just model support lines on these beams. So I'll just model one support line. I'll copy that support line over for each of the beams. Notice I'm not needing to extend these to the slab edge. The new features in version 18, let me go ahead and delete that one. The new features in version 19 do not require that, so there's some new improvements there as well. And here we have a series of beams. Now if I was to design the beams as they are currently input, I'm going to go ahead and generate the design sections based on the new coding in version 2019, and we get an effective flange essentially, or a flange that is the full tributary width of the beam. That means the program will integrate over this path the set of actions, the moment, the shear, etc. for that particular strip is what that strip will be designed for. So this section that you see, a T section, this B dimension here is equal to what is actually modeled in the system. Okay, if we say, well, we want to somehow modify the width of that strip so that it equates to some effective flange, I could use splitters. I could go in and say, well, let's just create a splitter. I would have to have some way to dimension this to either side of the beam. You could use construction lines. It could be part of an imported CAD file. Ultimately, I'm going to model a splitter along some path. So I'll put a splitter there, and I'll put a splitter there. And I'm actually going to do this for this other interior beam also. Okay, once I do that and I generate the strips again, you can see here that the tributary strip actually gets cut off at the splitter. So let me add a couple of more splitters so we end up with a gap in between the two, in between the strips over the beams. Okay, we'll do that. All right, so we have now our effective flange modeled. So now when the program integrates over this, it only takes the actions over that path and it designs this section for those actions. We're left now with this void where if we wanted to make sure that the slab is completely designed, then we have to go in and actually add additional strips here and here. And those might be considered, for example, a middle strip. So that's one way to handle tributary flanges in version 2018 and previous. And that's the way that users have typically been guided to design those beams in that respect. Taking this a step further, I'm going to go ahead and just delete out these splitters. I'll regenerate it. It goes back to its full tributary. Now for any design strip, we can go now under design section options. We're going to ignore the design width limit here, effective flange, and I'm going to select user defined. This only requires, or it really only allows the same width on either side. So for an interior beam, your effective width could be done this way. I might say, well, the effective flange overhang per manual calculation is going to be, 4 feet, okay? And I'll do the same thing here. We'll say that this is also 4 feet. And one more. So rather than adding splitters, we could approach the same problem in this manner. We could generate these strips, and you can see now we have flanges of 4 feet. We might also add something to the outside beams as well to avoid this completely extending over to this boundary for this tributary. This is another way to handle this. In this case, the program would again integrate only over the path of the design cut. Here you would get again actions, and we would design this shortened stem, or excuse me, shortened flange for those actions. You would still have this void that would have to be taken care of by additional strips. Now another new option is the capability again of the program to calculate the effective flange for us. So if we go to these design strips again, these support lines, I'm going to set this back to none. I want it to integrate over the full tributary, but I want to limit the design width to the effective flange. Okay, and that's the setting here we'll check in this last run. We'll do that for these 3 interior beams. When I generate the strip, oops, let me check that one again. I need to set this to none, and this one should be set to none. One more time. Okay, so now we have our full tributaries. In this case, the program will integrate over the full path, so we're not left with a void region, but the design of this particular strip is going to be based on the effective flange. The flexural stresses, when we have post-tension beams, will be based on the effective properties, whereas the pre-compression gets based on the full tributary. So it's a similar approach to what happens in our program ADAPTBuilder. We'll go ahead and run an example here. I'm going to select the slab. I'll add some loads to the slab. We have some loads. Let's go ahead and mesh this. And I'm going to analyze this slab for strength, dead, and live. Okay, once I analyze the slab, I'm going to design some strips here. So let me go back to my default display. I'll reset this view. I'll design this interior beam, and we're going to design the design cuts on that beam. If we look at the design cuts for this beam, let's go ahead and open up a section at midspan. You can see this is the full tributary path. It's 30 feet. This geometry is based on this tributary width. However, the idealized design section that the program is using to design reinforcement, to calculate stresses, etc., those are based on the effective flange, and that effective flange is here at this location. And you can see this rebar is relative to the calculation per the effective flange. So we're integrating over the full path to obtain all of the design actions, but we're designing per the effective flange. If you have any questions about this upcoming feature, please contact us at support@adaptsoft.com. Thank you.